Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I'm Nancy Boehm. I know a number of you came from places other than MSR. Welcome and thanks for coming by. We're delighted today to have Brian Whitman from the Echo Nest talking. I noticed that we also have our next colloquium speaker, Ian Condry, back there a couple rows, so come out on November 14th and hear Ian speak as well. But today we get treated to Brian Whitman, who I think is a very interesting person for this lab because he combines our social media interests around music and taste and collaboration and things like that with the machine learning kinds of interests of a lot of people in the lab. He is the co-founder and CTO of the Echo Nest, which is located in Somerville but has offices in other exciting parts of the world. He is also a musician. He got his master's degree in computer science in natural language programming in Columbia, and a PhD in the no longer existing music listening group in the MIT Media Lab in 2005. And he's more interesting than I am on these matters, so I'm happy to turn this over to Brian. He'll talk for about 40 minutes, and then we'll have Q&A, and then we'll have some treats afterwards if you really want to follow up with him or just eat. So please stick around. Thanks.
Thanks, Nancy. All right, thanks everyone for coming. Sorry about all the hurricane and weather and stuff. I'm glad you're all sitting here.
You should do something about
Yeah, should have done something about that. It looks beautiful today, though. Anyway, so Nancy gave a good introduction, and I'm not going to add too much to that, but I just want to tell you what we'll be talking about today for the brief time I have here. The world of music is changing. The company I founded 7 years ago is doing quite a lot with it. We are embedded in most things that you probably use on the internet with music, from guys like Spotify and Vivo, BBC and MTV, all those guys all over the place. But you probably never heard of us. That's cool. We're kind of a hipster startup where, we're just only the cool people know about us, and that's all right. So now you will be one of the cool people. But really, yeah. But yeah, you are now all officially cool. Finally, I've been waiting for that. But this is not a pitch, obviously. I don't need you guys to buy my stuff, but I do want to tell you what's happening with music data and how this is all changing and how you guys could possibly help if you're interested in this kind of thing. So to get started, I do want to just focus on why we're doing this on music and not something else, why we didn't start a company about books or movies or anything. So I was once a musician. After going to grad school and starting a company, you realize that you don't have time to do this thing anymore. And also, I was having a lot of trouble getting noticed as a musician. This is a very, very common problem. Nancy has done a lot of work looking into how people get out there on the internet and all of that. But back in the day, and this was late 90s or so, I was living in New York City trying to afford rent, but also playing a very niche style of electronic music, which I'm just going to be really optimistic here. I probably had 500 fans, let's just say. That was but I was putting out records. I was performing at least once a week. I was playing at some dilapidated warehouse or guy's basement or whatever, but I was making an effort at it. And I was putting out 7 inches and 12 inches and CDRs and CDs and getting on other people's label compilations and all that, the things you're supposed to be doing. And yet I just running up against this kind of why doesn't more people know about my stuff? Maybe it wasn't very good. That's one very obvious answer. It's very possible to this day. I'm not really sure if it was any good or not, but I thought that there must be a way to figure this out. That there's got to be a way to get your average musician that's really trying and working all their personality and life and passion and everything they're doing. Why is it so hard to get people noticed? And especially pre-internet explosion days, it was much, much harder than it is now. There was obviously physical media. There was Rolling Stone and Tower Records. There was, of course, Napster was just starting when I was a musician, and I thought Napster was amazing because I could upload all my stuff and people would actually download it, usually thinking they were trying to download something else, I had a really good musician friend that actually was pretty successful early on. He would rename his files like, his DJ name, say it was like DJ Wizard or whatever. It would be like DJ Wizard featuring Aphex Twin, DJ Wizard featuring, whoever else was famous at the time, just so people would type in Aphex Twin, see his thing and say, oh, it must be a remix, and download it. This was the way people discovered stuff. Amazon obviously was around, but it was really hard to get into or get noticed. I used to go into record stores that would sell my 7-inch and actually move my record to the front of the, just because it was yellow and it looked really nice, and I thought that would make a difference. It didn't. But anyway, this is pretty much where I come from, right? So I was also a computer scientist at the time. I was trying to figure out what to do with my life, as a lot of us are. I sort of still am trying to figure that out, but at least I have a little thing I can do these days. What I can do these days is try to get at what I think of as the ultimate hidden variable problem. All of you in this room, probably know a lot about science, machine learning, or math, or whatever, and you can sort of see music discovery as a two-ended problem. You've got people, you've got musicians. Musician emits some signal. Hopefully a person can hear it, maybe not. There's something in the middle there that's converting music into preference or taste or discovery or anything. And so many people have been trying. And it's for a computer scientist, I'm sure a lot of you know the connection between music and computers and how so many of your computer friends are also musicians or love music. And there's something about music that connects to this. But it's so many people, and there's been hundreds and hundreds of startups or companies or ideas around this idea of, can we help people discover music automatically? Is there something I can do as a computer scientist to make music more accessible? So that's been great, and it's been amazing to watch over the past, I guess now it's been about 15 years of watching this work go on. But what ends up happening is terrible stuff like this. This is a result from iTunes Genius of a Britney Spears song, Hit Me Baby One More Time. Their result was the report on pre-war intelligence by the Senate Intelligence Committee. And this is what's called collaborative filtering. I'm sure a lot of you people in this room know what this is, but it's more or less, people that buy X or listen to X, and I also buy Y. You can relate to people to their things in a big SQL table. You do a SQL join, you get a bunch of stuff out, and you sort of have a probability map of, well, based on activity, let's figure out what people are doing in music and try to recommend stuff.
You can also reveal some very private information.
Yes.
By coming up with weird juxtapositions.
Yes.
Of
Absolutely, yes. There's a lot of weird stuff in that. And so from a computer scientist perspective, yeah, it's a great algorithm that works really well, but from a music fan's perspective, or someone that cares about music, it falls flat in so many ways. This is Amazon showing recommendations for Sgt. Pepper, just showing you the other Beatles albums, as if that's useful. The way I like to see this is, if you're working on a recommender, you can optimize for whatever you want, really. You can optimize for people to get excited about music. You can optimize for more independent stuff to get noticed. And what Amazon does, and a lot of other guys do, is just optimize for sales. They're really just trying to get you to add stuff to your basket. It's like an end cap at a terrible, supermarket, showing you, oh yeah, I should get that one too because whatever. But this is not a discovery platform as much as they like to claim it is. A recommender here is being used for nothing but just, I want you to buy this as well. So we need to be aware of this and how it's working. I was buying some transistor the other day. This is actually last month, and I got a recommendation. It's a recommendation service on I think it's like DigiKey or one of these electronics component stores, recommending me a rotary shaft seal IP66 based on a transistor. And it's the stupidest thing in the world. It was like you could see the web developer clicking the box in his CRM maker tool that he's using, show recommendations for this page, and it opens up some really bad algorithm. And he's just like, yeah, that'll be great. Maybe we'll sell more stuff if we show that little box down there. And that's like the farthest away I want to be from this kind of stuff right here. This is the end result of 20 years of probability science and user behavior analysis. We get garbage like this. So we should avoid that if possible. One thing I built about a few years ago was this thing called Future of Music, and it's a thing that actually does a collaborative filtering recommender on your personal collection and then shows you the stuff that doesn't fit in the model. So it actually tells you that what the stuff that you have that you shouldn't like anymore. And this was like, just me being a jerk and all that, because, that's just who I am. But it was a really funny thing to run, because it's like, those models that we put all this faith in and all this, we go on Last.fm or Spotify or Pandora and we just listen to music. And that's so important. Like you learn so much from music and it's such a big part of your life. Why are we giving it away to computers if they do stuff like this? And the great thing about this is, you hit the scan button and it scans your iTunes, and then you click the delete button, and without asking you or putting it in the recycle bin, it just deletes it from your hard drive. I gave a demo of this once and actually ran it, and I was like, oh no, I lost it's like this guy here, DJ Heck, was actually my brother, for example, so I deleted his music by accident. Anyway, so we should be aware of this stuff. It's really important. So I want to get into sort of what people like us and other guys have been getting at to try to sort of solve this problem. We call it music understanding, and I put the scare quotes over understanding because, especially in this room, a lot of you know what this really comes down to. It's about counting how many times you see something and putting it into a statistical model. But we could call that understanding because it does do something useful for people if we do it right. A lot of the field that I'm in, it's called music retrieval. It's sort of information retrieval, but on music data, either score data or audio data, or now a community type data like using social network stats or what people are saying, using a lot of natural language processing stuff. But there's a whole field now. It's been going on since, I think the first Izmir, as it's called, conference was in 2001, I believe. And there's stuff like, segmenting music based on how it sounds, automatically detecting the genre of a song or the tempo of the song, all sorts of stuff. And a lot of you these days use music retrieval stuff without even knowing it. Top right, I'm sure everyone has seen that. That's your iPhone or Android doing Shazam, which is an amazing futuristic thing that listens to music, detects some statistics on it, and then asks the server what the song is. That's, it's not doing anything really that exciting, but it is amazing, and that is music retrieval. There's stuff that, syncs your tempo to your jogging speed and then plays you songs based on that. Using things like iTunes, sorting by artists is even music retrieval if you look at it that way. The field does a lot of different things, and this is sort of the way I sort of classify what people are doing in the music retrieval world. It goes down from just basic search and retrieval stuff, picking out the key or the tempo of a song automatically based on just the audio, tagging automatically, like classifying what genre this is, or if someone says this song is sad or happy, that kind of stuff. Automated composition, like sort of making music automatically based on all this, and then doing recommendation prediction, or even hit prediction, meaning given a song, is the song going to be a hit or not, based on some latent statistics that we have of it. The way I've always watched this is this here. It's kind of the creepy scale. The harder stuff, it tends to be more creepy. And this speaks to a really important problem in this space, and I'm going to keep telling it to you over and over again, that having a computer trying to do something with music, and I've seen this, I've been in the industry now, whatever it is, for the past, 7 years, selling our stuff all over the place, and we keep running into this problem. Some of this stuff is just too much for people to really get to and understand. I think guys like Pandora have done a really good job making it very nice and easy, and it's not putting too much onto you and not showing off too much of what it can do, because it is a really complicated, weird psychology thing. Why is a computer telling me what to do? Music is like the most important thing in my life. How the hell can a computer understand it? So it's a really thing to watch out for here, is the more deeper we get into the let's unpack music.
But Pandora does, I say I like this artist, give me that artist.
Sure.
So that is
They are doing
taste
some of it. They are doing recommendation.
But you're saying that they aren't creepy in the sense that they
humanize
they don't pull from some weird clusters, or what is,
they-
why are they not creepy?
Well, I do think we'll get into their creepiness level here a little bit. I don't want to slag them publicly or anything.
I don't find the recommendations creepy, but
Sure.
you say that they stay away from that. So
Right, sure.
You're
So-
saying that they could be giving us more
Right.
and they're not.
Imagine a recommender that looked at your Facebook stream and said, "Oh, you just broke up with your girlfriend. You must be sad." Imagine it. It probably exists. Someone has probably made that, right? Is that creepy? Yes, we all agree that's creepy. Yes. So there's a lot of signals that Pandora doesn't use that they could use, that they could make. And what they've done is, and they've done this amazing thing of just becoming the new sort of edited radio, more or less. Like the same way you trust your radio DJ, which might not even exist anymore, you now trust this sort of team of music genome editors, they call themselves, to do this stuff for you. And so I think they've humanized it in a really important way, and that's really important when you look at their success versus other guys that have tried this. So I want to just talk about Eigenfaces for a second, because I wanted to show this picture. This is the beautiful Eigenfaces picture from Sandy Pentland from probably, 20 years ago now. Just looking at statistics of just pixels, more or less, and images, and then figuring out what people are doing with all of this. There's an important lesson here in how you analyze a lot of music and do a lot of stuff with it to look at work like Eigenfaces, which is used now all over the place for facial detection and all sorts of weird stuff when you go into an airport. Looking at sort of what people look like over a large swath of time, you get to see a lot of some symbols that pop up over and over again. You look at, they all share a same nose feature, an eye feature, or whatever. So we thought we'd try that with music, and this was a project we did about 10 years ago called Eigenradio, which was the same thing but on music. So we listened to 100 radio streams at once, constantly in real time. This is all over broadcast radio. and then try to figure out, what is a computer doing when it actually tries to listen to audio like this. So this map down here is quite similar to a lot of the feature extractors that audio or music retrieval systems use. You take an FFT sometimes, you do PCA, you try to reduce the dimensionality of it. You do a bunch of stuff, you figure out where the important stuff is, and then you make sense of that. So I thought what we could do is just invert it, and then hopefully we'd hear what the computer hears when it hears music, and it sounds like this. And this is, 100 songs at once, just playing through the system. It's not very listenable, right? Too much bass. There's that. You can hear a beat. You can hear all sorts of interesting things, but what's going on here? I'll stop that for a second. Another experiment we ran early on was looking at collaborative filtering at the extreme. Looking at a collaborative filtering algorithm running sort of on its own for a lot of iterations, like in a simulated model. What happens with collaborative filtering is it suffers from this known, it's called a popularity effect, more or less, where popular stuff will keep getting recommended, but unpopular stuff, since no one is buying it or listening to it, never gets in the system, so to speak. People don't get enough interaction with it, so it never gets recommended, so people don't get interaction with it, and it causes this feedback loop. And that's a huge issue for collaborative filtering that people still deal with these days. So what we actually did was take...
How does Netflix find sort of the movies which are out of the mainstream?
Netflix has a great problem because there are about 1% as many movies as there are music artists even. They can do a lot of other stuff since they have, their database of movies. I think it's like 100,000 or something. It's not that much, and they can do a lot of tricks to make sense of that. But our database right now, we have 30 million songs and 2.5 million artists, and there are artists in there that I promise you no one has ever listened to, or the song that no one has ever even played. So we have to deal with a separate set of issues. So just to show what this output here is looking at more or less a matrix factorization.
You can ever do with the
Right.
with the person that no one's ever listened to,
Well,
except throw them in randomly sometimes.
So I'll get
Try to detect if you're his mother, then
Very good. So
Unless you just broke up with him.
exactly, yeah. Unless we know your Facebook account. So what we're looking at here, though, is that the 9 artists that remained. So what happened was, after a while in the simulation, artists just stopped getting plays or buys because they fell out of the feedback loop, more or less, after many iterations. So we were left with these 9 artists. This is the end game of just a purely collaborative filtering world. Here's what we're stuck with. And I love the clustering of Bob Dylan and Chris Isaac. It makes no sense, right? But it's this weird, what could have happened if we kept doing these kinds of things? But luckily we didn't. Where I started doing this actually was this review here. This is actually my brother Keith. He shares my last name. He's also a relatively popular drone musician. I'll show you some drone music in a second. But this is pitchfork.com, Pitchfork Media. They're a really popular music review site. And they have this rating scale. And it's like this kind of, very regal thing in the world of music. They give a rating between 0.0 and 10.0. And he got a 9.7 for this record, which is super high and very rare. And it was amazing, and he sold tons of records, and it was great for him. This was 2002, I think. And this is the review, and it's really long and talks about a whole bunch of stuff. And I was just thinking of reading this review when it came out. I was in grad school at the time, and I'm like, how the hell could anyone do this just based on the music alone? So let's listen to this song. This is the first track on this record. It goes on for 20 minutes. I'm only going to play a couple seconds of it. But think about the machine learning problem here. What if you could take the audio from any song or anything really and try to predict the rating, like how well people would react to it? And then you give it this, right? What's going on here, right? It's obviously there's something that has nothing to do with the audio is happening. What's happening is my brother released a record at a right time and people responded to it well. He's referencing older music from the computer music era of the 60s or 70s, and whatever's happening in the underground drone or noise world or whatever he's in, people are now receptive to this, and there's this long, super long review. Most of the words are not really musical words. They're about where he is and who he is and the context around it. So obviously there's so much more than just the audio that we should be looking at when we do this kind of work, obviously. We can't just take those sine waves that I just played you and predict how successful it'll be. Actually did try to do that. This is a big regression we did of looking at audio features and then predicting if we could rate the review. And I'm not going to give you the R scores here and everything, but it just didn't work. There's not much in there if you just look at the audio. One thing we did prove was that certain review sites are more predictive than others, but not by very much. Like Pitchfork, which I just talked about, tends to talk a lot about external world things that aren't very predictive, whereas AllMusic Guide, which is a much more stable, popular review site, they're more predictive, but not by much. Other things we looked at, if we could detect sadness automatically from a song. We already talked about this, but this is another hilarious problem in the world of music retrieval right now, which is valence, they call it. Can you take an audio file alone, no context, and detect whether it's sad or not? The answer is you can't really. There's not much in there to do that for. You can detect a minor key, you can do other stuff, but it doesn't really get to the heart of the matter, really. And then we looked at, can we detect Christmas music automatically, which is very apropos for the upcoming season. Another really hard, very full of context, not just in the signal. And what we did was look at a bunch of audio from Christmas songs and train a model. The model failed.
No bell that was there that wasn't there?
You'll see. So what we then ended up doing was inverting the model again, like the Eigenradio example. And this was the first computer-generated Christmas song. So tell me if you think this sounds Christmassy or not. There you go. Anybody? No? No? Nobody?
The right level of annoying.
Yeah. You hear the melody?
It's just like the other one, except you never know.
A lot of it, yeah. You hear that melody? Anyway, no, you don't. Okay. I'm going to stop this. All right, so that was my intro. I'm going to talk to you, though, now about the Echo Nest and how we do it and how it works in general in the world. So I like talking about care and scale when you're doing music analysis and stuff, and I'll tell you what that means. But first, this is our office in 2005. It's a tiny room. A lot of you are academics, I'm sure, researchers, and have thought about starting a company. You should buy me a drink and ask me about how that went sometime. I was a PhD at MIT, graduated, started a company the next day, went to the lawyer's office, signed the documents, moved into this room here. It's been an interesting time since then. We've done really well. We're now 50 guys, tons and tons of data. We've got offices in London and San Francisco, and mostly here in Davis Square. Tons, and we have all the customers that we could possibly want to use our stuff, and it's been amazing to do. But the way we've kind of done it, though, is based on all the stuff I just talked about, like how people have done terribly at it and how people do it kind of strangely. We quickly narrowed in on this kind of care and scale thing. And for me, this is the 2D matrix that we should all look at when we're doing this kind of work. Care for me is this helpful? Are we actually doing something useful when we make a recommendation or try to predict someone's taste? Is this result useful? So that Amazon result I showed you before of showing the rest of the Beatles albums, not useful. If you go to most recommenders and type in the Beatles, you will probably get Paul McCartney, Ringo Starr solo, George Harrison solo. Like, that's obvious, it's true, it's a good result, fine, but it's not helpful. No, you're not really being a useful discoverer of music for anybody. Scale is more important to me sometimes, which is we have to know about everything. So Pandora, which we talked about, they obviously are really good at care. They've got guys, music editors, music writers that love music and care about music, but they fail on scale. They've, to date, scanned or typed in data about 1 million songs. We track 30 million, or actually more now. And that, to me, is like the biggest failure of what Pandora does. When you're on Pandora, you're not going to be discovering brand new stuff that no one's heard before. They suffer from the exact same popularity bias that collaborative filtering does, because they have limited resources. They can only scan so much music a day. So there's got to be some bridge between the two, and that's sort of what we're trying to get at here. So if you look at like editorial, like Pandora, where, as I said, high on scale, high on care, low on scale. Collaborative filtering, I think they fail both. The scale problem is there, and also the results are terrible, and I don't know why they're doing it, so I think they're over there. We'll talk about pure audio analysis in a second. But guys that just look at the signal and figure out, what's happening in the signal, what's the tempo of this song, and like I played you that Eigenradio sample, like giving a computer that kind of sound, let's figure out what other music sounds like this. Obviously, you can scan every song in the world really quickly if you wanted to. You can boot a bunch of machines and do a bunch of scanning, and you're done. But the results are just not that good. And yet there's been so many companies that try to use this process, and they always just have these terrible, terrible results. And so obviously they fail on the care thing. So I'll talk about sort of how we do it. So I have my co-founder, Tristan, who also is at MIT. We met there. he does some really amazing audio analysis work that actually is much more musical than what I've shown you before. More or less, you'll take a signal and you'll chop it up into what we'll call segments, which are sort of what the human ear perceives as the song goes on. So yeah, every note of a guitar solo, every syllable of a vocal line is chopped up. And for each one, we can tell you the pitch of it and the loudness and the timbre, which is sort of how the sound sounds.
So does he do this in an overlapping way?
It's
or
not overlapped. It's just it's segment. They're disjoint pieces, but each one is a variable length. So they could be really long if the song is slow. So it's not like a windowing thing. It's like if it's a slow song, there's less segments because each one is longer, and they're variable as the song goes on.
Slow, so are you going to tell us, like, is it characterized by the amount of information
Yep,
in it?
you could do that, yep. Right, so yeah, that happens as well. And then he does a beat tracking on top of that, obviously, so you want to know, which is separate from the segments. The beat tracking is sort of a more periodic, how often are things happening in the song. And a ton of stuff comes out of this. We compute features like danceability, which is how danceable a song is, which is based on sort of the energy in the bars and how they happen, how they're spread apart. There's stuff like energy, just general, which is how energetic the song is. That's also based on sort of the loudness over time kind of stuff. Anyway, all this data is publicly available. We have an API, which, if you guys are interested in this stuff, you should definitely be using. I was just telling Nancy, we give away all of our data to researchers and non-commercials for anything you guys want to do to build stuff. It's all available. And I can get into that later. The other half, which is actually where I come from, is all sort of looking at what people are doing with music on the internet. And actually the company, the way it worked was because the audio analysis was so compact and fast and it worked right away, Tristan's stuff was amazing. The rest of the company is much bigger. We do this kind of Google for music operation. There's probably like 20 guys working on, crawling the web and parsing for language, parsing social network data, all sorts of stuff we can, and it's really a complicated thing. What we do is we look at every website in the world that people talk about music, and there's tons of them. There's blogs, there's record review sites, there's social media, both the counting kind of stuff, meaning how many people liked this artist on Facebook, down to what words people used on this weird, music forum that people are on that we're also scanning every day. So we get all of it. And what we end up with is this vector that we call our cultural vectors, more or less. It's called community metadata. I used to write a bunch of papers about this in my academic days. I'm sure they're all terrible, but you can read them if you want. More or less what we do is we compute features that are sort of, it's analogous to an audio feature or just a vector you could feed to a machine learning system where you have a probability per feature. But our features are phrases, they're adjectives. Like this is the band ABBA, obviously. Things like Swedish or non-violent for some reason got some high ranks there. And this stuff changes all the time. So what happens is we crawl over the place, we generate these really super long vectors of description about the artist, and we throw that into our databases, more or less. And then to compute similarity, we sort of combine both the audio stuff and this stuff as well.
So those are the different features in the feature vector.
Yeah. We also add in a bunch of data we get from our partners. We work with all these guys, a huge list of companies, and they also give us a ton of stuff, which has been great for us because the more companies we work with, the smarter we get. For example, we just started working with Vivo, who do, they trade in super popular videos. We're able to analyze all that stuff. We work with Twitter, so we're able to look at their whole social graph whenever possible. So the stuff we can't crawl, we also get from people we work with, and that's been really, really useful for us.
What kind of audio features do you use? How do you
Audio features?
Yeah.
So that was this. That's the Tristan thing here. That's all this. So it's the segments. So we denote each segment, and each segment impacts to a timbre vector, a pitch vector, and a loudness vector. And there's usually between 1,000 and 2,000 segments per one song. So it's a huge. You can get it. It's a big JSON file you can download. And yeah, we discrete. Yeah. So to do the similarity stuff, we then do global features on top of that. We look at like the covariance over time of the timbre, for example. So what we usually say is, this is like kind of a rule of thumb, for every 5 megabyte MP3 file, it unpacks about 20 times its size with all the other data that we collect, all the audio data, all the text data, and that's how much we have to store. So we have 35 million songs. You can do the math. We have a lot of data in our databases. So what do?
You presumably find that there are lower dimensional spaces that are more contain.
We don't need all of it, right?
Right.
But we do index all of it. We don't need all of it. That's true. And I'll show you how it's definitely getting used differently. So I want to get into phase 2 here, which is talking about the music experience and what people are doing with all this new stuff people are building. So this is iTunes. actually an older version, but we call this sort of spreadsheet music these days. This is what it looks like. It actually looks like Excel when you open it up, right? You've got just a list of song titles and really nothing else. And it's been what people have dealt with for a good 10 years. You have this huge collection. You've got 5,000 songs in it on average about. You type in on the top right and you get a bunch of songs back. But what we've been seeing with the explosion of all this new data and all these new features that people are getting access to, the music experience is very, very quickly changing. And that's been more interesting to me than everything else we've been doing. So this is a great example of an app someone built on top of our platform, which is called Hugh Sound. And what it does is actually browses music by the color of it, the color of the album art. Which has been like, if you've ever been a lonely night or whatever at home and you look at your CD collection and you want to rearrange it by color, well, this is for you. I'm not saying I've ever done that or anything. I would never do that, but I'll just say I sympathize with this man here. And it's so silly and stupid, right? But also it's like, it's a great discovery tool. Click on yellow. Oh, I remember that record. Oh, it's a great record. I want to listen to it now or whatever. You know, what's this really bright green record? I've never seen it before. It's just one little feature that we calculate and can get out that now people can use to do stuff. Obviously, more interestingly, looking at all the audio data we have has gotten people to explore music in new ways. This is a great instrument that someone made for the web called Bohemian Rhapsody. Note the pun there. And it's a song, Bohemian Rhapsody, chopped up into the segments I was just telling you about. So each one of those boxes, and they're colored differently by the timbre, is a different piece of the song Bohemian Rhapsody, and you can play it like a keyboard. So you can actually, it's mapped to your laptop or whatever, and you can just play it as a song. There's a little video of me trying to play the song here. See, I'm playing the end of the song piano part. Now mixing in stuff from the beginning. I'm really good at this. Yeah, see. Anyway, that's like, you can imagine doing this for any song. It doesn't matter. We have this data for any song in our database, and you can split it up into this piece. More recently, someone built this too, which is very embarrassing. There's this very popular song called Gangnam Style, and this came out over the weekend. One of our developers built it at a Music Hack Day in Iceland, actually. What it does is, since it chops up the song into little pieces, what he can do is predict or detect when you can loop it properly and then move it around the song so that it plays forever, more or less. It'll never stop. This is the video of it going for just a minute. And you can watch the green dot there skip around the song. But you won't even notice. This is now the verse, and it's not going to skip in the verse because it knows that the verse is different from everything else, so it's going to keep that alone. But once it hits that blue dot, it's going to move probably, and you're not going to notice. There. Now it's at the beginning of the song, right? So you're lost. You're like, oh no, I'm stuck. What's going to happen? And like it's seamless because of the way we do our segments. This is all over the internet now, obviously, and people are like, I watch it for 10 hours. I'm going to kill myself. You know, it's like really, because like it never ends. Anyway, a form of discovery, let's call it that. And I'm going to stop that for you guys. Another great one was like manipulating a song to make it sound different. This is another thing that hit the internet about 2 years ago based on our stuff. It's called the Swinger. What it can do is actually change the time signature of a song to make it sound different. This is going to be Guns N' Roses' Sweet Child of Mine. You know what that sounds like, but the swing version automatically can do this for any song. And what's great about these, they're toys, right? They're funny, they're toys. But what happens is people, like, they build a web app and people upload, all their songs and they trade them and they show their friends, and it's been really great to see. And it's like a great explosion of how you can manipulate music and also get something out of it. And then obviously the obvious stuff. So we power things like Spotify's radio, and that's been just amazing.
How can you actually do that? So I, as an artist, might be. So there's one thing that allow you to copy my music or my paintings or so.
Sure.
But I'm not sure that I'm allowing. Are you allowed to take my painting, cut it in pieces, and sell it again in different versions?
I'm not a lawyer. Is anyone a lawyer? No. I don't know. It's actually a very legal gray area. You're absolutely right. Yes. It's a moral question. Wow. Let's talk about that one later. I think. Hold on. I think giving the tools, making the tools available to people to do stuff like this, I'm okay, right? I'm totally okay with where I stand on that. The guy that built the web app that lets people upload songs, he might be in some gray area there legally. I'm not morally then. I think morally everyone's fine, and I'm not sure what you're going on. We'll talk about that one later. Anyway, so just the more, obviously, the bigger stuff we're doing is powering a lot of radio experiences now. This is Spotify's radio, which has been great to see. Clear Channel, which is like one of our bigger customers here, they use all of our stuff to build their iHeartRadio app, which is great because Clear Channel, you think of them as like the big lumbering beast, but them using Echo-Nest style analysis, you can type in any artist in the world and get really good results now on a Clear Channel powered station, which has been really great for me to see. I can type in my old band, and all that kind of stuff and get results. So that's been really great. Really cool new experiences. Like there's a great iPad app called Discover without the E at the end, but it shows you this beautiful graph of all of your artists, and you can see how they're related. And it's just a really nice way to sort of, they all jiggle and wobble when you move them around. It's like a spring effect. And it's a great way to see how everything's related, and you discover new stuff based on this, because there's a different way of looking at your music. Through all of our analytics data, like how people are doing on the internet, how artists are being tracked on social networks, we power MTV's new chart, which is called the Music Meter. So instead of doing their normal top 5 or 10 or whatever, they're now looking to the internet and companies like ours to power sort of new ways of tracking artists. And that's been really great to see. So you can go on MTV now and see brand new artists that obviously don't have videos, they're not that popular yet, and yet MTV wants you to discover them, and it's in their best interest as well. So that's been really awesome. This is my favorite new music website called This Is MyJam. We work with these guys. They let you post your favorite song once a week. That's the whole limit there. Just one song once a week, and that's it, and it'll go away after a week. And it's a great, very mini social network for just discovering one song versus the total spam that Facebook or Twitter will give you with all your friends doing all this stuff all at once. It just limits it to the really good stuff, and that's been really fun to watch. And another thing that we're really into these days is music resolving. So we have an open source fingerprinting solution called EchoPrint, which is actually something that I worked on quite a lot the past couple of years. So it's Shazam, more or less, but you can build it yourself and add to the database yourself. Which for me, going back to my earlier point about being a musician and not being able to get yourself out there, a lot of musicians are having trouble with Shazam because people will be in cool coffee houses listening to some new CD that some guy got at a show, and they won't be able to Shazam it because Shazam kind of locks down the data set there, which is actually a point of control that I'd like to remove. I don't think they should have that control over what can be resolved because so many people are discovering music based on these tools. So we built EchoPrint, which is sort of Shazam-like. It does a lot of stuff differently, and it works very differently, but it, at the end of the day, does fingerprint songs and tells you, what they are. And the first thing that someone built with this was actually nothing to do with music, and I was really excited. It's called Ad Hoc, and you can use it now. It's a free app. What it actually does is it detects political ads on your TV, and it shows you who's funding them. So it took all the music stuff, and that we threw all the music stuff out, and filled the database with political ads, and then when you use it, it's like, oh, the guys behind this are this PAC or whatever. So it's been a great way of just seeing what people can do with this stuff that's not very obvious. So I want to also briefly talk about the million song data set and big data. A lot of you here probably work with data sets or want to look at statistics of music to use in your research or whatever. This is something you should know about. We built this with Columbia University about 2 years ago, and what it is a downloadable data set of 1 million songs. It has all the metadata that we collect, all the analytic data, all the social network data, everything you want to know about 1 million songs. And so what you can do is throw it into your cluster or just load it into R or whatever you want to do and just see everything you can about our music without having to hit our API and do all this stuff with it. It's been really successful. A lot of people have built really cool stuff just using this downloadable data set. This is an overlap matrix of terms that people use to describe music, based on different genres. And you can see really cool patterns emerge and stuff like that. One of my favorite apps was this one. It's called Search for Music by drawing a picture of it. And what this actually is you draw, and it's a web app, you draw a loudness curve. This is probably like Stairway to Heaven, right? So you can see it gets really quiet, and it gets really loud, and it tapers off a bit. And then you hit search, and it goes and finds it, because we have all that loudness data over time, and it does a search real time and finds a song and comes back with it. So it's really fascinating to see stuff like this come out. Another really cool one was looking at drumming over time and how messy it is. This is since we have tempo for every segment of the song. This is So Lonely by the Police, known for being a really sloppy but obviously very soulful drummer. you can see that his BPM is -4 and then +4 up here. So this is the variance in BPM as the song goes on. So it's you feel the song kind of get faster over time, but also you feel sort of the sloppiness in the song. But on the right there is a Britney Spears song, obviously a drum machine or edited all to hell, and it's just totally flat, So it's a great way of looking at sort of, dynamics of music. Or we can look at stuff like location data. So we have, for every song or artist in the world, actually just artists for this, where the artist is from, what they call their hometown. We get this from either their biography or from the labels, or we get it from Wikipedia, wherever we can find it.
Seattle is so far down.
Yes, this is the top most musical cities. These are the number of artists that claim to reside in these cities. And since we have 2.5 million artists, we can do this huge, very quick calculation of this kind of stuff. And so, yeah, what this guy did was he looked at the population of the city over the number of musicians and sort of did a musician per capita kind of computation here.
This is just, even so, Princeton versus Berkeley.
Can't argue with the data. It's just data.
Well, yeah, you can argue with data, but anyway.
Not this data.
Right, exactly. There's an arrogance index in there, too.
Oh, yes.
Somebody
Oh,
calls
definitely.
themselves a musician.
Yes, there's that. Yes, there's definitely that. We could talk about that one, yeah. This is just a map of the same thing, but yeah. So I want to sort of wrap up in the last section here on something that we're working on now. It's a really big new thing for us and also for the general industry in general. It's the taste profile or just music analytics on people. So when I talked about care and scale earlier, sorry about that.
Kale is good.
Kale and scare. Kale and scare. That's good. It is Halloween. When I talked about kale and scale earlier, I talked about different recommenders like collaborative filtering or looking at audio analysis or all sorts of stuff. But what people haven't been doing much of yet, and this is really a big problem, is looking at how people interact with music. And I think this is kind of one of the final frontiers of recommendation or taste prediction or whatever you want to call it. Looking at how people are not just like what they like and what they rate and what they skip and ban on their social networks, but also just like when they do it, how they tell their friends about it, what else they're listening to, what movies they watched last night. Again, to get creepy here, did they just break up with their girlfriend, that kind of stuff. Is there something we can start doing by looking more at how people are interacting with music, the statistics that come out of that, and hopefully doing a lot better recommendation. So I mean, obviously Facebook, we all use it or hate it or whatever we want to do, but it's got a ton of data that links people and brands and movies and all sorts of things all over the place. And I just been watching them sort of fumble with music a little bit. They have their music app now. It's been out for about a year. It hasn't really done very much yet, but you can bet that somewhere deep in the bowels of Facebook, they're working on this exact problem. And what we've been looking at, and I can show you some really cool graphs and numbers about how we've been doing it, is sort of like what we can learn from people's music preferences. What more that tells us about people than just what music they like? Can we predict demographic data or all other forms of media that they're watching, that kind of stuff? So we actually built an API. It's out now. This is our API page, by the way. If you're a developer, you can hit all of our endpoints to get all this data back. And one of the things we built was actually a timely sort of, little press tease that we can predict your political leanings based on your music. So what we did was we got from our partners and from crawling a lot of correlations of people's favorite music and who they plan to vote for. And then did a big machine learning thing on, this is on about 5 million or so different profiles. We published our results. It got all over the place. This is one of those, press things where my grandmother called me and told me she read about me on the news or whatever. It was really amazing. We got, headlines like that. But the results are interesting. So what we're looking at here is we just sort of did a two separate classifier of self-reported Democrat, meaning I'm going to vote for Obama, self-reported Republican, George Bush, McCain, or this other guy, Mitt something or other. And just looked at sort of, based on the music taste, how can we do predicting stuff using not just what artists you listen to, but the features of those artists. Like if you said you liked Fleetwood Mac, I know that that's Fleetwood Mac, but I also know that they're sort of a folk rock band from the 70s or whatever. We have more information about that than most people do. We know what their music sounds like. We try to figure out where we could fit, the features of all of our stuff into that prediction. And we did pretty well. Our F1s are pretty good comparable to other things. We did worse for, I think we did worse for Democrats than we did for Republicans, but it's still pretty good. And the cool stuff we got out of this was, sorry, I didn't know this was going to happen like that, looking at the artists that were high correlators, not just the ones that most appeared, because that's usually the most popular artists, but the ones that laid on the decision boundary, more or less, the ones that were the most predictive of either side. And this is really cool stuff we can do to show, if you like, Kenny Chesney, you're probably a Republican, that kind of thing. And then the other side, obviously, is a lot of hip-hop and top 40. Some of it is really obvious, and a lot of it you don't, no one needs to be told any of this. But much further down on this list is a lot of really interesting data that really speaks to people's preferences.
What would be really interesting, I think, in something like this would be to look at this over time, because Pink Floyd in the
So Pink Floyd,
70s or 80s would not be predicting that you were a Republican.
That's absolutely
right?
true. So when I
It's really
so that's actually even Elvis, yeah. So when I ran this, so I'm actually a Syd Barrett Pink Floyd fan, so meaning early Pink Floyd, like the first 2 records at most. Actually really dislike later Pink. It's one of my, so actually I have this problem. I have a lot of artists I like are actually multiple artists. Like we have to split them apart almost. And that's actually something we're doing internally at the Echo Nest is, so the Beatles is a great example of this. Obviously they went through multiple, whatever, different tone changes. And a lot of people say, oh, I like the Beatles, but only up until Please Please Me or whatever, right? And there's something we can do here. So Pink Floyd, though, even with the Syd stuff and all that, like, still is really high correlator, which is interesting to look at. So even after all of that, averaging Pink Floyd.
Even like you.
Yeah, even me. So,
like
but I wouldn't.
The part that you
right,
would still be a top.
That's an interesting point. You would never self-report. I would never self-report that I like Pink Floyd because I know that people would assume I meant the terrible Pink Floyd, right? So unless Facebook lets me like Pink Floyd, Syd Barrett, parentheses, right? Then until they do that, it's going to be really hard. Yeah.
When you do these predictions and you're saying it's the most predictive, is that after you're controlling for other demographic information? Because otherwise you might get something that predicts an artist that predicts that you're old would be the most predictive,
yeah, sure.
doesn't have additional.
Like Elvis Presley or
Interesting, yeah. No, we don't do that. That's interesting. That would be a good way to do that, yeah, because we do have that. We do have self-reported other demo data.
We actually have a researcher in the New York City lab who is doing tons of political polling. He's doing it on Xbox now, but he's collecting all this data. And I think it would be really interesting to make some of those corrections with
that would be great, yeah.
with this.
So yeah, cool. We should talk about that because that's interesting, yeah. But the other thing I want to show in this, again, this weird build here, this was the class confusion ones, meaning the ones that had the most confusion between the two sides. And this is just the top 5, but it was an interesting list. These are the ones that if you told us you like these guys, we really added no new information to the model.
Well, it's like the Republicans try to use, whose song were they trying to use?
They always do this,
what?
yeah. I think they used the National recently. They got really mad.
Right. So, I mean, it's like Paul Ryan loves music that...
Yeah, he likes Rage Against the Machine. Yeah, he really got into Rage Against the Machine, but they were like, yeah, screw you. Yeah, stop listening to our music, bye. But I love this.
Yeah, we'll be predictive of Republicans.
Right. So the second 2 here, Pantera and Moonspell, are both pretty heavy metal groups, which is interesting to me because I don't know how that happens. But the list is actually the top 10 list. You can look. I published most of it on my website. You can see all the lists much longer if you want to. But they're very metal oriented, so there must be something about metal fans, or they're very confused.
But you may be right, actually, that these may be artists that are very associated with a time.
Yes, absolutely.
Okay,
Yep.
And so with a relative, so with people's youth, right? And then
I will hopefully. Well, I'm not going to answer your question on this, but we're trying to fix that because. Well, first I'll show you this. Hold on, I'll get back to you in a second. But this is another great graph we showed on here, which is actually the diversity of the music, meaning the different types of styles of music that were self-reported. And the blue line is the Republican line. So this is a bucketed histogram. It's a hard graph to explain, but it's the average number of features we got for the different groups here. So Republicans, on average, a takeaway here is they listen to less different kinds of music, and I can get into the details there. But that was another funny. Again, this is like shooting fish in a barrel. We're in Cambridge right now, and I don't want to be mean, but come on, So to get to your point, another thing we're doing is looking at sort of bucketing people, automatically clustering them. We have a cute little web app where you can just based on your music, and we know what we call years active of all the artists. So Pantera, I don't think is playing anymore. Their years active probably ended in 2002, let's say. So we know when artists are active, and so we can use that as sort of a proxy to get at age if we don't already have it. And so we've done other studies on other demo predicting stuffs. This is our RF1s on different topics here. Again, we can do gender really well, but that's pretty easy. We can do age, but also what's cool is like we looked at the research for doing age prediction based on stuff like web history or, you know, like your first name or whatever data people get, and we're actually doing pretty well, like much better than the other published results I've seen of doing prediction based just on the music data. So obviously, age and music is a huge predictor of age because you're listening to stuff that was out when you were that old. So it's good to look at. What we're not trying to do, and this is really.
What is relationship?
Oh yeah, self-reported, married, single, in a partnership or whatever. Yeah. There's this company that we don't work with that I don't really like, and this goes into the creepy world, and this is great because they published this thing called Beluga. This company's called Grooveshark. They're sort of like they steal a lot of music and they let people access it. They're a funny company, but they did this. They're trying to sell ads now, which is what everyone's trying to do. And they did this thing where they gave people surveys on their site when they're listening to music, and they show you this market research for bands now, and it's the creepiest, grossest thing I can imagine, because the best one was Neil Young. I just typed in Neil Young to see, because I know Neil Young would really appreciate, some company trying to correlate ad demos against his music, and yet here it is. The top one is over-the-counter non-prescription medication. That's the number one. People that like Neil Young also like over-the-counter non-prescription medication. So sad, so gross. Anyway, it's happening. I'm just telling you it's happening. Get ready for it. It's not. Just to wrap up, and another thing we're looking at now is looking at sort of statistics of the stuff we were just talking about. So we have these things called, this is a hard graph to look at, I'm sorry, but this is one of our customers' collection of users plotted, doing this in MDS on all these features that compute on people. So given one person's music taste profile, we can tell you what we call freshness, which is like, when is the average time that their music was active? We can take all those years active data and just show you, on the whole, are there artists popular in the 1999, or is it more like 2012? Are they listening to recent music or not? And you can look at these really simple numbers across a huge swath and sort of pick out different groups of people that are doing different things and say, oh, that's interesting. Part of my customers are always listening to the new top 40 music, and some of them are kind of stuck in the past.
Well, it may also be whether they have teenage children or
Yeah,
not.
there's that too. So that's, yeah, so we're actually, well, a lot of them are interested in that. There's sort of the declustering problem of, we have an account that obviously is listening to a lot of Lady Gaga, but also listening to a lot of Creedence or whatever. Can you help us split them apart so we can, hopefully guide them both? And that's why we're doing stuff like this, which is looking at, this is, you can see the clustering here happen of plays versus listeners of bands that they like. This is what we call the passion index, meaning do you listen to the same artist over and over again, or are you listening to a wider swath of music over time? And is it less focused? And it's really cool. You can sort of see the obvious things that pop out. So there are groups of people that just aren't down the middle, but there are some down here that are, super passionate about their music. So anyway, just to wrap up, because it's time to go. A lot of things are happening in music. We are, working with all this data and trying to make it better for everybody. There's been this explosion of different ways of accessing music and, discovering it and all this. But I want to make sure that the people that are doing it in the right way, and that are they're caring about music and also just treating it properly. And that's where we come in. So thanks very much, guys, for listening to me. Yes.
So I'm older than most in this room, and I must say I miss the old DJs,
Yeah.
the old radio stations with good DJs, which we still are around.
Yep.
And I just wanted, has anyone looked, or have you looked at just getting playlists from DJs from
Yes.
all around and seeing what you get out of that?
Absolutely, yeah. We're actually doing that now. That's a big push because the big thing that's happening are people like yourself, not just older people, but normal, everyone really wants to hear something curated. They want to hear something that someone chose, especially if they can respect or trust that person. We've been going through, the John Peel Foundation has published all of his, and it's been amazing to look at those playlists, because not just the artists he chose, but how the order in which he plays them and all the features you can play. It's an amazing set of data. And that's John Peel is very famous BBC. He died about 5 years ago, but he was one of the biggest tastemakers in the music industry for a long time. And not just guys like John Peel, but any radio DJ really in any college station, just watching what they're doing and what songs they're picking. Absolutely, it's a huge treasure trove of data that a lot of people, not just us, are looking at
So
now.
you're using it, or you think trying to figure out how to use it?
We're trying to figure out how to use it now, but I know there's other companies that actually will just play you those playlists, like as a Spotify app or whatever. You can just listen to that stuff right now. But we're trying to use it more statistically, like why did they choose those songs, and how can we predict what John Peel would have played, you know.
So that you can simulate John
Simulate
Peel
John
after
Peel,
his death.
which is not creepy at all. It's totally fine.
That's interesting.
Yeah, he said it was
John Peel.
Yeah, it's right there.
I'm wondering about lyrics
Yeah.
And how that could be incorporated. And I mean, I do think, you know, if I'm asked what music do I like, I'd say, you know, things like Tom Waits, the
sure.
Pixies, Leonard Cohen.
Yeah.
You know, and to me, there's a real logic to
Right.
their sensitivity to lyrics. And I noticed how Pandora is hiring all these
Yep.
musicians. I thought, well, poets are cheap.
Yeah.
You know?
So let me ask you, do
Hire
you
some
like
of
Rod
them, they
Stewart?
could probably do similar stuff. Is there efforts of that, or is that, I suppose it adds a
There
whole
is, yeah. So my
complexity.
flip question was, you missed, was do you like Rod Stewart? Do you like Downtown Train, you know, composed by Tom Waits, or would you think it's the same song when Rod Stewart sang it in '85 or whatever? The lyrics are the same, right? But I don't want to listen to that Rod Stewart version, right? So there is, obviously lyrics are important. We do look at them. We do statistics of lyrics. It goes into our models. I have to say that it's not as important as I thought it was. Like we all had the same idea that you did, which is like looking at lyrics are really valuable because people like interesting lyrics, but they're hard to process. There's a lot of metaphor and stuff that much more complicated than music, I think, you know, is the weird wordplay and all that. So I think someone hasn't done it that well yet, but we're trying. And I'm sure Pandora is as well, yeah. Yeah.
Thinking about Rod Stewart versus Tom
Yeah,
Waits.
sure.
If some, something comes out about a certain artist, does that change people's taste?
Yeah.
I mean, do you see like news events essentially?
Yeah, absolutely.
Have
Yes.
an impact
Yeah,
on taste?
we've done those studies. We actually track news really, really carefully. It's one of our biggest sources of input, actually, is like, especially for popular artists, like when Whitney Houston died, let's just say, I mean, we could easily, that's an easy one. Like you can predict that all of a sudden everyone's going to like Whitney Houston, right? But it's a lot more subtle than that. There's a lot of stuff you can do to feed that model. So yeah, it's a big push of ours.
Right. So I mean, part of it may
Yeah.
be just who Tom Waits is versus
Sure,
who Rod
of course,
Stewart
of course.
is
The
and
story
what
around
that-
Tom, of course,
right,
yeah.
and what you see
Yeah.
Rod Stewart doing
Right,
in the
of course,
media.
yes.
And so it's
Like,
distasteful
right.
to hear him
Who do you
Tom Waits.
identify with more? You know, the
Right.
Rod or the Tom? I guess I'm a Tom. Anyway, yeah, back there.
Could you comment a bit on how good hit predictors are now?
Yeah, they're not. So actually, I'm not joking. Like they don't work. People that say that they do are usually liars. I'm being honest. Like the companies that do them are usually run by ex-label huckster type guys. That really what they do is they tell you they're feeding it through their system, but it's just a panel of their friends. Like, yeah, that one sucks, whatever, and they'll charge you $100. There's something about the hit prediction thing that it obviously rubs me the wrong way because it's a really not useful thing for the world. It doesn't help anybody, but also that I don't think that can work. There's something, so you can say there's two sides of this coin. One is a hit predictor is a global recommender. All you're doing is saying, will the world like this song? That's one way of looking at it. The other way is, is it even possible to predict the future, right? That's sort of what they're doing, right? They're trying to predict the future. And I think it's more on for me, it's on that other side, meaning there's so much about the world as a unit that you can't make all these assumptions for that you could with a normal recommender. It just falls apart. And I've seen all the technology as it is. It doesn't really work. I've never seen it work in practice. The guys that have stories about how it worked he predicted Norah Jones or whatever, I think it's all BS, and he didn't really do that. So that's my
Aren't there
summation.
studies that indicate that if you recommend music, more people like it more? And so if they
absolutely,
think
yeah.
they're so, I mean,
Yeah.
doesn't that indicate that
Yeah.
there's some positive
Yes,
Lyapunov
there's
exponent
absolutely,
that's
right.
driving
Yeah.
you
I
to
think
some,
there's,
that it's very unstable
Yeah.
what becomes a
Yeah, you guys
a
hired
hit.
Duncan, right? You have Duncan now from Yahoo?
Yes,
He
yes.
did that study, I think it was
Yes.
10 years ago. And that was amazing. That's pretty much what that showed, yeah. So there's a lot of stuff there. Yeah.
So for the recommendation systems in terms of how you can judge your approving things, like I'm very sensitive to your comment about, like Amazon is a thing. What I want to see is influences and not, but Amazon is easier because they want people to buy things, so they can optimize for that.
Yep.
And Netflix, it's clearer. So how do you get a feel if your recommendation system is good in any
And what's the
quantifiable
difference
way?
between wanting to buy and recommending, by the way? I'm not Sure, a good recommendation is also a good buy recommendation.
Because people don't buy things anymore.
No, but buy is quantitative, right?
It is. So what we measure now, actually, it's a big push in our company, is to look at listening length, which is what we do right now. So we power things like, we power a lot of Pandora competitors right now, which is like you type in an artist name, you get a radio broadcast, more or less. And people tend to skip, they tend to listen to it for an hour, they'll shut it off. Whatever, and we can look at those numbers coming back. So we always have that feedback, and that's how we measure how well we're doing. I want someone to listen to song, so on average right now, our average listening length is 7.2 songs or something like that. I want that to be a lot longer, obviously. I want someone to be like, this is amazing, I want to listen to it every day, you know, and that's our main thing right now. I also have a feeling, like when I look at our results, I can look at them and say, okay, these are good, I'm missing somebody, there's a bad guy in here, I don't know why. That's also how we do it. It's very manual.
But even though that seems odd, right? If I'm looking for influences, right?
Yeah,
I just
absolutely.
kind of jump through,
Yeah.
right? A lot of the time you'd be very satisfied if someone clicks through 10 different things, right?
What you're touching on is this is a very qualitative, weird, fuzzy, emotional world that we're in this music space, and I think that of all the companies in it, we're doing the best at it, but we're still aping a very complex system that none of us understand. We could use stuff like session length as a proxy, but it's a really rough proxy. Yeah. So any other questions? Yeah, right there.
Do you have any, are you involved in these kinds of apps that are focused on feelings, that if you want a tender song or a mood agent and things like that?
Yeah, so we don't power mood agent, but we do power a couple of their competitor types. We have that data. We get it mostly from the text people say, so they'll talk about a song on a blog and say, this is a very sexy song. We don't try to do any audio analysis there because I don't think that really works. We do a lot of mood based on the words people use to describe music. We just parse it and put it into our database.
Second question.
Okay.
Would you be able to do this on books?
So yes, I think a lot of it is applicable to books. Echo Nest is a music company. We're never going to do anything else. I'm personally interested in the book question, but that's another topic altogether. Yeah, I think not the content analysis. I don't think looking at the words in a book is useful. Maybe it is. I'm not really sure yet. But definitely what people are saying about books and how it's being traded in social networks and all that, I think is really useful. Yeah. Cool. So yeah, over there.
Music is moving so fast that there are a lot of credits that are being eliminated from the analysis of music.
Yeah.
So this is a synthesizer.
Yeah.
Where was it recorded? Who
Yeah.
recorded it?
Yeah.
Did that person have an influence on the sound that we're hearing?
Yeah.
Is the research going to continue into these areas also?
Yeah. Sadly, not as much as I would like. That's a big sticking point of
being a musician.
Yeah, no, it gets me, and I have seen the data labels collect and keep and how they transfer it. There's no good standard for sort of what we would call library-style metadata on music. It's a huge problem. They're trying to get on one now, but it's really bad, and I've seen I'm not getting into politics now, but it's when you have all these companies that are having a lot of trouble, you know, and even guys like Spotify, you know, doing really well, and yet they're still struggling for profits and all this. It's a hard world to think about the important stuff like that for them. They don't, because people, you and I care, but honestly, on the average, people don't tend to care about who played the synth on that Lady Gaga record. It's sad but true right now.
Yeah. You just posted the things about the drums.
Yeah, the Lynn drum.
Where did you get that?
I got on Wikipedia.
You just posted a song list. All the best songs have this particular kind of drum.
Drum machine, the Lynn drum, which is like, you know, so I know this stuff because I'm a dork like that. But yeah, we're going to lose a lot of that, and it's sad. And the Echo Nest, like, I would love if we could do it, but I don't think it's going to happen. I hope that someone else shows up.
But
yeah,
do people want to know it? So I even have that problem. You buy some reissued, I don't know whether it's classical or non-classical music. You don't get the text of the songs anymore. You don't get. You just get, okay, this is this album, a new reissue, sort of remastered, whatever, but no information.
Yes, I know. It's annoying, but I don't know what to tell you. I'm sorry.
And one other one.
Sure.
With the degradation of music from the AIF to translate into MP3s and then take an MP3 and make an AIF out of it. Like, where are we now just in terms of, is this the original recording?
I would say most pop producers are mastering for MP3 right now, even though they'll obviously create an uncompressed master from Pro Tools. They are mastering it so it sounds good on iTunes and Spotify, and that's just the way it is.
Can you determine with your software whether you're listening to an AIF or an
Yeah,
MP3?
you probably could. I haven't seen that. That'd be interesting.
That's what.
Because obviously we all know about the loudness war. That's a big one right now. Or just because of these, like our laptop speakers or our iPods, the louder the better for a lot of listeners, and that's destroying the dynamics of most music these days. And it's been really terrible to watch. Again, it's a capitalist force that I'm sorry that I can't help you with right now, but maybe someone else could. So should we keep going, or it's up to you?
Maybe we should convene for.
Yeah, we can. I'm gonna.
Out there and
you can
continue
keep
the
talking.
discussion.
I'll just be right. I'll be right there.
Yeah.
Thank you guys
Thank
very
you.
much.